First, we have to define our variables, and it will help tremendously if we carefully draw a picture. So in the figure, this is the printed area. Okay, my text will go here. And if you follow the question carefully, there will be a 1.5 unit margin on top, the same in the bottom, and on the left hand side and the right hand side there will be a 1-inch margin. I'm defining the width of the printed area to be X and the length of the printed area to be Y. Y is larger than X. That's what I'm trying to do here, and it has to be done very carefully. Okay, if X and Y are the dimensions of the printed area, then this whole rectangle, the sheet, which includes the margins, has to be X plus 2 by X plus 3. It's a very important step, and you want to do it very carefully. So let's repeat. Based on the picture, we define the dimensions of the printed area to be X by Y, with X being smaller than Y. If that's the case, the dimensions of the sheet must be X plus 2 by Y plus 3. It's an important point and it's worth repeating. Okay. We need to find the dimensions of the page that will minimize the use of paper. And the area of the sheet has to be X plus 2 times Y plus 3, and that's our primary equation. The area of the sheet A has to be X plus 2 times Y plus 3. The constraint. The constraint is the printed area has to be 24 units square. Therefore, xy is equal to 24 is my constraint. Our constraint x times y is equal to 24 implies y is equal to 24 over x. And we are going to replace this value of y with y in our primary equation. And we get this. X plus 2 times 24 over x plus 3. And if we multiply these two quantities, x plus 2 by 24 over x plus 3, we get 48 over x plus 3x plus 30. Now, we're going to find the derivative of a with regard to x. And if you do it carefully, you will get this. 3 minus 48 divided by x squared. So the derivative of a is 3 minus 48 divided by x squared. Now, we're going to set up a prime is equal to 0, which would imply 3 minus 48 over x squared is equal to 0. And we'll have to solve for, we are right here, we'll have to solve for x. And the algebra isn't that difficult, and you will see that x will turn out to be plus minus 4. If that's the case, we are only going to select the positive value of x because x cannot be negative. Now from our constraint, we know y is equal to 24 over x, and we divide 24 by 4 and we get 6. So we determined that a prime is 0 when x is 4, and when x is 4, y is equal to 6. We can use the first derivative test, the second derivative test, or an appropriate graph to show that the function a of x reaches a minimum value when x is 4. We're going to do it graphically, but you can do the first derivative test or the second derivative test. It's totally up to you. I have graphed the function. A of x is x plus 2 times 24 over x plus 3. And this is my graph. And you can see when x is 4, a reaches a minimum right around here. And of course, you should know how to do it using calculus. The first derivative and the second derivative test will help you with that too. But I like graphs because it makes it more concrete for me. And the conclusion is the dimension of the paper has to be 6 by 9. Recall, the value of x was 4 and the value of y was 6. So 6 plus 3 is 9 and 4 plus 2 is 6. That's the answer. 6 by 9 is the paper that I need.